Thanks for attending the talk. So I'm the first one. Sorry. So today I'd like to share a use case that we have done lately at Sky with you guys. Not sure about how much details I'm able to provide in 20 minutes, but if anything that I didn't cover, please feel free to come to me afterwards. So a little bit about myself. My name is Xiaolan. At the moment, I'm a lead data scientist in Sky in the Insight Decision Science department. I have a PhD in computer science, specialized in social network analysis and building a personalized recommender system. So you can find me on LinkedIn or write to me directly via email. So generally, this profile just says a little bit more about myself. So I like coffee. I drink coffee a lot. I play mobile a lot of time. And I like to explore interesting spots. So there's a guy from San Francisco, and I recommend you to have a walk around the old street. You will see spots like Banksy drawings on the wall. It's a very nice spot, and the bar as well. So a little bit about the environment that I work in. And so we are the biggest pay TV provider in UK. So a lot of content you will be able to find on the Sky Q and also over-the-top streaming service like Sky Go and Now TV. We also have a separate app for Sky Cinema and Sky Kids, as well as Sky Sports. Lately, we provide the Sky Mobile services as well. So when this service come back to us, it is all about the data. So we have data about media content, no matter if it's video, audio, text, texture, metadata. We also have customer consumption data. So we collect people who watched what at what time, like Netflix, not like everybody else in the market. We also have customer service data, like transcript of complaints or problems people are having. We also collect hardware diagnostics data, like the TV box, trying to understand what the problem people are having. We also purchase third-party data to enrich whatever we have in-house. So based on these kind of a very diverse data, what do we do in the team? So quite a lot of different projects. We try to identify key drivers for business KPIs, help the business make better decisions. We also do customer preference modeling and content personalizations in the marketing campaign. We also do a churn prediction as well, anomaly detection. So a lot of people are probably trying to get the Sky content via different channels. Some people are trying to do streaming illegally. So we try to build up anomaly detection models to capture this kind of a behavior. A little bit about the platform we have. So all the use cases that we build up basically is based on the in-house Hadoop cluster. So we use a lot of Apache Spark. We basically use a lot of Apache Spark machine learning library. We also do a lot of POCs with Python scikit-learn. Recently, we moved towards Google Cloud Platform, where we are able to try different models with TensorFlow and GPUs. So basically in-house and on the cloud, we do have a lot of facilities available and build up capabilities. Let's come back to the case study. So today the main topic I'm going to walk you through is about tag suggestions based on the movie synopsis. When we talk about movie, a lot of time when you go to friends, you would say, oh, this is a great movie. For example, this 10th Cloverfield Lane. You would suggest, it's great, very small group of actors, very great storyline, build a lot of attention around it. That's what you talk about with your friends. But if you don't have any suggestions from your friends, when you look at this movie, then you probably look at what the catalog would provide you. So on the TV box, you would see there's a very short description about the movie. Synopsis, so it says, it's about a woman involved in a car accident, wakes up in a cramped underground bunker with two men she's never met. 10th thriller with Mary Elizabeth Winstead and John Goodman. So it's released in 2016, and it's about 109 minutes, available in HD. That's all what you know about, right? So you will make decisions based on a synopsis. So in-house, we have some media people trying to give you more information on top of a synopsis. So they try to give you free text tags. For example, this one, it's tagged as action thriller, alien thriller, disaster action. So a lot about the free text tagging, right? So this basically allows you to look up the movies based on this kind of, let's say, theme-related descriptions on the tags. And then we also provide you saying this is a big genre thing, so sci-fi and a thriller. And if you're interested in a movie about from a certain producer, then this is a J.J. Abrams movie. So these are the textual informations about movie that you will be able to see on the TV box or from the streaming services when you don't know about the movie. So we took a snapshot of the data set, basically this kind of texture movie metadata set from 2016. I know it's a little bit old, but it gives us a little bit kind of impression about what we have in the movie. So we got a collection of about 80,000 movies across 17 genres. And these movies has been tagged with more than 2,800 free texts. So each movie has been tagged, can be tagged basically with one or more than one genre, one or two most of the time. And each of the movie can be tagged with one, nothing, or many free text tags. So for example, the tags you could see is like based on novel or comedy drama or whatever we saw before, disaster, action, those kind of things. When we look at this collection of a movie, we notice drama, comedy, thriller are the biggest theme. Most of the time, they are always the biggest one. And drama alone actually contributed more than 40% of the collection of the content that we looked into. The second biggest category is comedy, which actually is already smaller than the half size of drama, and followed by thriller. So if you think about all the movies that you watched in the previous years, probably they all fall into, most of them fall into these three categories. So musical and the documentary are the smallest category that we have. So if we think about movies, indeed, not many documentary or musicals that you could find. Movies of different genre, they have been tagged very differently. So when we try to look at how they are tagged, basically we took 3 random tags and look at the frequency of those 3 tags in different genre. So I have a kind of a donut plot here. So how to read it? So basically, if the bar is very long, it says that tag has a few occurrence in that category. While if the bar is very short, closing to the center, it means the tag is very popular. So movie of that type is very popular in that genre. So we have observed movies of a different genre, they have this kind of different distributions across tags. So if you look closely to documentary, which is on the bottom left. So you will see crime thriller and romantic drama, they actually don't exist in this kind of movie, which makes sense, I guess. And a few movies have been tagged as based on novel. So probably those movies about documentaries about novels, stuff like that. And if you look at drama, which is next to documentary, you will be able to see that basically all the 3 tags are very, very popular, which also reflect to what we have just seen before. So crime, drama, thriller, they are just the popular themes around the drama. So tags is able to basically tell us a little bit about different genre of movies. And when we look at movies of the same genre, we found they have been tagged with a very big vocabulary, very differently. So we took these three very big category of content and looking into the detail, what are the top frequently theme around the content. So when we look at the drama, basically drama movies have been tagged with more than 1,700 different type of free text. The top one is TV movie. So I was actually asking around what type of movie would be TV movie. Anybody know? No? Okay, so there are movies supposed to be released in cinema, but they didn't actually went to cinema. They will go to TV channels. Those are the movies called a TV movie. And apparently, we do have a lot of those movies. I guess that's a kind of a nature distribution of the movie industry. So across the drama, we see a lot of TV movie. And we also see the big chunk of them is about crime, based on real events or relationship drama, classic drama. So if you read those free text words, you basically kind of get an idea. So apart from genre, probably there are different themes around the same category of the content. However, at the moment, we are relying on a lot of human behind the computer actually watching the trailers and read the commission materials to summarize this kind of a theme and tag it manually. And similarly, comedy and thriller, if we take a closer look, they all have been tagged very differently within the category. Each of them have more than 1,000 different type of tags. And if you look at those top tags, you basically think about what you have watched in the past years. I think it's kind of more or less reflected on the distributions. One interesting example that we have seen is in the comedy. So there are tags about British film. And there's another tag I didn't show here, but just followed by the friendship comedy is black comedy. So when we did some case study in the past, we had some kind of theme, models around the theme based on tags coming from the US. We tested it in-house, and we found it works very well on the US content, but didn't really work on the UK content. However, we are a UK pay TV provider, so a lot of content actually we are not able to get the inference out of the model. So basically that suggests they are part of the work. We still have to rely on the local media experts, or probably we can build it in-house, not rely on the US models. So just a little bit sum up, some movies of the same genre, actually they have a very different tags. Then when we go back to look at the synopsis, trying to understand how media people or experts trying to summarize the content. So the synopsis that we have had in the collection of the data set come from different channels. So part of them are coming from the distributor directly, part of them coming from the third-party provider, and a lot of them coming from media experts in-house who actually watch a lot of TVs, or their daily job is just to watch TV or read the text materials for the TV content commission. So when we look at the vocabulary of the synopsis, we have noticed that across 18,000 movies, we had more than 32,000 vocabulary. And the synopsis is quite short, actually have the average length of 18. When we look at the distribution of the words, basically we see that it's really, really long-tailed. If we look at the top frequency words, so basically we see starring, drama, HD, stars, minutes. So you kind of get ideas. There must be a pattern lying in the synopsis. So a lot of time, people are trying to encode who are the stars, what is the main genre of the movie, the duration of the movie, the release year of the movie, and the format into the synopsis. So this is a kind of pattern that we observe by looking at the synopsis. So we started to wonder whether we can actually, using some algorithms to understand whether there is any pattern apart from what we just see, could be summarized from the synopsis. So the first attempt that we did was using latent Dirichlet allocation, topic modeling. How many people are familiar with this? Cool, so I don't need to explain. Just to give you a little bit brief information, what does it do? So LDA model basically takes all the documents, reads the text. So the assumption of this algorithm is giving all the text information. If the words always happen together in one document, they kind of form a topic, and one document could be about many topics. So this algorithm would be able to give you kind of a bag of words outcome. So a group, basically a topic is a group of words with every words, how much it attributes to the topic. And then on the document side, it will basically tell how many, with the distribution of the topics for this document. So when we do apply this algorithm on the synopsis, there are some interesting pattern actually started to show. First of all, we didn't see the pattern of release year. I guess that is the nature of the algorithm, because the release year, if you consider at the word level, it's just one word, so there's no concurrency thing. But when we look at the bag of words, let's say topic, so we started to see something like Christmas, Santa, case, family. So could say, okay, it's a kind of a theme around the Christmas and family. And another type of example we see is a horror, supernatural, thriller. So it's like crime and a thriller, supernatural. So let's come back to the topic distribution, the example. So we give the synopsis, and then by feeding into the LDA, we are able to understand the distribution of kind of topics or themes about the movie. But again, so that gives us basically another kind of a thought. So we already have the media experts tagging them. They are more extracted or abstract information, more accurate than the topics. So whether there is a way for us learn this kind of a knowledge by reading the synopsis and the tags, by building up some basically algorithms to learn the relationships. So that's another exercise we did as a follow-up. So we went to look into the sequence-to-sequence learning. Anybody knows about it? Okay, so I have to go through this then. So when we build models, a lot of times we are trying to basically make predictions, right? Giving the features or attributes, then we try to predict a value or category. So that's the common problems we are handling every day. But the problem here is a little bit different. So we are actually looking into a many-to-many relationship. So we have to look into a mechanism. Basically, we'll be able to learn a sequence of words and then output another combination of words, right? So sequence-to-sequence model is a kind of a deep learning model that comes to rescue in this type of problems. So if anybody interested in the detail about this kind of a model, we can have a chat afterwards. I will just give you the idea here, how we actually put it into our use case. So we tried to basically simplify the problem. First of all, by simplify the things we want to predict. Basically, we want to predict the keywords of the tags, not the tag itself, because we think keywords is already descriptive enough. So the sequence-to-sequence model have two parts. One is encoder, another is decoder. So encoder is a recurrent neural network. It learns the relationship of the sentence, the synopsis itself, outputs a context vector, and the decoder takes the context vector, basically is a kind of, let's say, compressed information from the sentence and feed it into the decoder recurrent neural network part to learn the relationship between the context vector and the keywords of the text. So a little bit results from our modeling. So we try to validate this model by taking the synopsis that we don't have in the catalog. So we went to IMDb, like everyone. So a few movies that we looked into is, for example, the Blade Runner. So we took the synopsis from IMDb. It says it's about a young Blade Runner's discovery of a long-buried secret leads him to track down former Blade Runner. It's very short, right? And however, our model actually suggests that here is action, adventure, classic, crime, horror, novel, sci-fi. And when we validate it with a genre from IMDb, it says it's mystery, it's a sci-fi, it's a thriller. I guess it's more or less, we are there, right? Anybody watched the movie? It's quite recent. Yes. Do you agree? Sort of. So that's why we say it's kind of a suggestion. So we give you an option, and it's around that theme, and you can choose the relevant word to describe it. Another good example is like the Manchester by Sea. So IMDb says it's just a drama. However, our model suggests it's not just a drama. It's also about friendship and a relationship. I think it's pretty good about it. So some things that we learned from the use case. We saw this kind of model has a lot of opportunities in automating content meta tagging. So now we show the tagging part. We could also use it to learn how to summarize the synopsis, giving the text information like the commission text material from the production. So for example, TV script directly. And we also see the potentials have this model in one-to-one retrieval tasks. So when I say one-to-one, it's kind of a single-turn conversation chatbot to answer simple questions from the customer. But we see it has a very big challenge in produce something creative because the model is not yet at the stage to learn the beauty of the human language, which actually is the key in the media. So we actually did a little bit use case and found out it fails to produce anything creative or beautiful language like what we write when we speak. And it is not ready for any consistent conversation customer support task. I guess I ran a little bit out of time. Any questions or?
For the encoder-decoder model, sec-to-sec, what is your target? Is it just the tags as a whole sentence?
So my input is the synopsis. To help basically to train the model faster, we have removed the stop words. Then to simplify the question, because the free text is really, really free, but we also observed basically quite popular words. There are words, appears a few different times. So we try to basically predict the keywords of the tag, not the tag itself. So the keywords, basically, if we go back to this example, what we have here is really a long selection of the tags. We try to simplify them into the word level. So yeah, last information, if anyone is interested in this kind of work, and our team is growing, so feel free to come to us.
Okay, thank you.